This is a quick look at a low volume production manufacturing of a so-called bearing housing made from a standard piece of heavy wall pipe cut into small sections, and then a recess is bored in each end to take a bearing, and finally a 8mm metric thread hole is drilled and tapped to take a grease nipple in the side. During the manufacturing process of these bearing housings, you'll see that each one is tested with a bearing race to make sure that it goes into the housing easily. It's machined to what's called an H6 fit, which is up to 0 to 0.02 of a millimetre, that's 2/100ths of a millimetre over size, which is fairly tight, and if you don't get them exactly right they can sometimes jam. While each one is tested with a race, they can be tested with a gauge, and you can see here that that's showing the 2/100ths of a millimetre oversize, but it doesn't indicate whether there's any marks or scuffs in the bore, which can happen in manufacture, and if they do, then the bearing won't go in. So the quickest and easiest way to test all of these is to actually insert the bearing race into the housing and remove it. The lathe will have finished the other end. Again, every part gets a check with the bearing. That one's done. Ready for drilling and tapping. Clean off the rubbish. Turn the bearing housing in the first end and change the mill. Quick blow to get rid of some of the rubbish. Oop, wrong end. Undo the locks, which don't really need to be very firm, because the parts just sit in the grooves of the miller bed. Make sure there's nothing for the next set of parts to sit on, so they get out of position. Whoop. Make sure we put the new part in, not the old part. We don't want two holes in each piece. Light tighten. Close the doors to stop the splashing. Press the go button. Take these pieces over for deburring. And meanwhile, the lathe has finished another piece. Sometimes when they're a good fit, they just don't want to come out easily. If they're the slightest bit pulled too hard on one side, they jam. Rotates quite freely. There we go. It's out. Turn it over. And hit the go button. This basically just blows off extra coolant, any rubbish that may have stuck to it from the machining operation. Now we need to remove all the burrs. and 300 left to go. Pipe on the rollers there, and that 12 metre length of pipe laying on the floor. Back to the lathe, which has finished the first operation. Check that the bearing fits. The screen is saying turn it part over. Which we do, and press the go button. And the next one is underway. So you get a small break. While the mill is now tapping all the parts that previously drilled.